Assalamualaikum. We are from Group 3 and in this video we will discuss about plastic waste. So here are the 3 articles that we chose to be presented. This is the subtopic that we will discuss in this video. So let's start with article 1, which the topics is engineering properties of a building's materials with melted plastic waste as the only binder, authored by Marcel Thiam and Mamal Daufal.
Low-density polyethylene LDPE is one of the most produced types of plastic wastes and has a low recycling rate. However, no previous studies have tested the use of LDPE as the only binder to develop concrete-like material. Hence, the objective of this test is to assess the possibility of developing a concrete-like material named plastic waste-free or PWC using plastic wastes, LDPE and HDPE as the only binder. The methods for sample preparation that I talked about in this article are preparation for conventional concrete with 0.5 water cement ratio, preparation for cement paste samples for microstructural analysis with 0.5 water cement ratio, and lastly, PWC with melted plastic wastes. The testing methods that are used are mechanical tests such as UCS, axial deformation and split tensile test, the hardened density test, microstructural analysis, thermogravimetric analysis, and absorption tests. From the result, they show that the absorption of conventional concrete is higher than in PWC. It's because the behavior of plastic used as binder in PWC is hydrophobic. Besides, the initial water content for PC-based concrete creates a larger amount of voids or higher percentage of porous areas in reaction with water. In addition, the immersion absorption of PWC 50, which is PWC that has plastic content of 50%, is higher than PWC 60, which has plastic content of 60%, which confirms the pores are more larger in PWC 50 than in PWC 60. In conclusion, the purpose of the study is to find alternative ways to recycle plastic wastes and reduce the pressure on the environment by using molten HDPE and LDPE as the only binder and creating new types of cemented construction material, PWC. A less analytical consuming method is developed to prepare for PWC. Microstructural, mechanical, and physical properties of PWC are investigated. We also found the compressive strength of PWC, the stress strain behavior, and the density of PWC.
Next, we will continue with article 2.
Biodegradable polymers which have become an integral element of human life in many forms. According to Sun et al. And Gupta et al., construction materials are very noteworthy since they require a large amount of raw materials and resources to manufacture. The method of using waste materials is possible to reduce disposal and landfilling space and reduce environmental pollution and construction costs. The factors that can influence recycling prospect is a scarcity of natural resources, the pace of industrialization, and population density. Some plastics such as PC, PP, and PVC can release toxic compounds as a result of chemical reactions that lead to contamination of the air, water, and soil. For the plastic materials type, which is food tray are collected as waste and washed to eliminate the impurities. And then the WPFT are cut by using the scissors to provide more standardized shapes. And then the clean plastic sheets are cut with a constant width of 2mm and 0.3mm thickness, and a length of 20mm to be used in the main experiments. While for palm oil fuel ash, POFA, firstly the POFA was dried and sieved to remove the larger particles and to lower the content of carbon. The particles are tested and analyzed based on the specification of ASTM C61805. For the testing method, there's workability test, compressive strength test, tensile strength test, drying shrinkage test, sorptability test, chloride penetration test, and microstructural analysis. So this is the result for the drying shrinkage test, compressive strength test, and the tensile strength test. Is the purpose of the study is to evaluate fiber reinforced concrete's durability made from waste plastic food tray as low-cost fiber and palm oil fuel ash. Based on the findings and observations obtained in this study, WPFT fibers can be added to concrete composite in order to boost the durability, efficiency, and strength. After addition of WPFT fibers, the compression strength of the concrete was somewhat reduced. Besides, by adding WPFT fibers considerably boosted concrete's tensile strength, resulting in higher WPFT reinforced concrete mix values than simple concrete mixes.
And last is the Article 3, which is recycling woven plastic sacks and PET bottle waste as fiber in recycled aggregate concrete.
Introduction. Plastic is a word obtained from a Greek word which is plastikos, which means fit for molding. There's two categories of plastic, which is thermoplastic, which is PET, PVC, HDPE, LDPE, and others. Then the other one is thermosetting, which is polymers that contain epoxy, silicon, and phenol. Technology. PET waste. PET bottle and woven plastic sack was cut into given dimensions. The waste were then cleaned and dried at room temperature. Physical and durability of fibers were determined and then added to the concrete. The compressive strength of concrete were measured at 28 days. Axial and lateral strengths were acquired by strain gauges. Testing method. There is about 4 testing methods, which is slump test. Concrete mixtures were cast into cylindrical steel molds. Then the concrete were stored at 1 day at 20 degrees Celsius. Specimens were removed from the mold and cured in water at room temperature. The splitting tensile strength test. It was determined with the loading constant of 1 megapascal per minute. And then a shear test were conducted, and also chloride ion penetration test. Of result that we get from the test. Okay, then first is properties of recycled plastic fiber. Fiber thickness of PET range between 0.1 and 0.52 mm, while rPET fibers range between 1.9 and 3.0 mm. Okay, then we go to compressive strength. We can see from the figure 2, it represented the compressive strength of all specimens in 28 days. Then into toughness. The toughness of concrete was defined as the energy absorption ability of concrete. We can refer to figure 3. And next, modulus of elasticity. From figure 4, it's demonstrated the result of elastic modulus of concrete for both NAC and RAC mixture. Then lastly is splitting tensile strength. On figure 5, the splitting tensile strength of RAC was 63% of NAC. It is clear that the rPET fiber was more effective than RWS fiber in the improvement of splitting tensile strength of RAC. This study investigated the effects of plastic waste on the mechanical properties and durability of RAC. SF and the proposed mixing technique played an important role in improvising properties of RAC. The potential engineering of rPFT and RWS fiber reinforced RAC can solve present environmental problems.
For critiques and recommendations, we can identify from the article proven that the plastic waste is a good sustainable product replacement for binder in concrete, and there is no unclear research work as the research work are all done successfully by testing a lot of tests, and we recommend to combine the plastic waste as a binder to save our environmental materials and support the eco. From this video, we can conclude that based on studies, plastic waste is a good replacement for binder in concrete, and it's found that plastic waste are good sustainable materials that can be used as replacement for binder to develop concrete-like material.